Instruction Skill 3 is solving decimal word problems with addition or subtraction. And the recommended computation review for this one is page 141. I'm on page 18 of the text. And let's take a look at this first example. When Trent had the flu, his temperature increased over its normal value of 98.4 degrees Fahrenheit. His temperature rose to the value shown on the thermometer. By how much did Trent's temperature increase over its normal value? So we know that his norm is 98.5. And if we really zoom in on this thermometer, let me try my best. I'm very much zoomed in, so this may not work. Trying to shrink that as much as I can. So his temperature is right here. All right. So it is between 100 and 101. This would be 101. And that interval, that's 1 degree, it is divided into 1, 2, 3, 4, 5 sections. So that 1 degree in there is divided by 5, and that is going to give us 0.2 for every one of those. So this is looking like 100.2 degrees. So his temperature has risen quite a bit. Now, to find the amount of increase, how much higher it is, I would have to take the 100.2 minus the 98.4. And we want to make sure that we align those decimal points. And notice there's not a calculator icon. So that means I have to do this the old-fashioned way. And I will need to borrow. Can only go next door. But then I can borrow, give to that one. Borrow and give to this one. 12 subtract 4 is 8. 9 subtract 8 is 1. And then, of course, these are zeroed out because there's nothing left. So we're looking at a difference of 1.8 degrees Fahrenheit, or number 4. Clinical thermometers. A clinical thermometer, like a ruler, has a scale that is a number line. However, unlike a standard ruler, the thermometer scale has 5 equal divisions between each whole number temperature. Each small division is read as 2/10. So what they're saying here, if you look at an interval on a thermometer, just like we did up above, so maybe this is the, let me just use what they did. We'll call this the 100, and this is the 101. And they're saying that there are 5 equal increments in here. So there, I'm going to just kind of guesstimate. It's pretty close. It's not exact. But this would be 100.2. 100.4, 100.6, 100.8, and then 100.1. So the temperature reading we're seeing above was right there, 100.2 degrees. So the way that we could solve this, there are two ways to solve it. Approach number one says to read the value that Trent's temperature reached, which is 100.2 degrees. Subtract Trent's normal temperature of 98.4 from 102 degrees. And this is the method I used. But here's another thing you can do. You can identify the point 98.4 on the thermometer and then count by 0.2 or 2/10 up to the 100.2. So here's what they're saying. If you find 98.4, which is his normal, that is right here, and you go all the way up to here. So you're covering that interval. Let me get a little bit smaller there. So you're covering that interval. How many spaces did you cover? Here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And each of those is worth 0.2. So you have 98.4. So this would be 98.6, 98.8, 99, 99.2, 99.4, 99.6, 99.8, 100, and 1.2. So that is 0.2 9 times, and that is 1.8. That way works just fine, but to me that is brain racking. I would much rather do it the way I did it, but if you like that way, you can use that counting up method. It's fine. Some points to remember. To add or subtract decimals, you always align the decimal points. Line up those decimals and work around that line if you're adding and subtracting. If you are reading a clinical thermometer, this is showing 97.6 because here's the 97 mark, and then each of these is 0.2. So there's 97.2, 0.4, 0.6, and that's where we are lined up. This one is showing 99.8 because we are moving from 99 and it goes 1, 2, 3, 4 intervals. So that's 99.8. And then this one is 101 and 2 more spaces, so 101.4. All right, let's take a look at the practice. We have concept, procedure, and application again. And we're starting with concept. The bar graph below shows the cost of electricity for selected states. About how much more does 1 kilowatt hour of electricity cost in Hawaii than in Kentucky? And the title of my graph is Cost of 1 kilowatt hour of electricity. We have Hawaii, Kentucky, and New York. And then on the vertical scale, we have 0 to 20 cents per hour. So each line of that scale is worth a nickel. Each time you go up a line, you're adding a nickel to the cost. So Hawaii is very close to 0.15. Kentucky is very close to 0.05. And New York is a little bit over 0.10. question is how much more. That is incredibly important. If you can, I would highlight this phrase because that means subtraction. Another subtraction clue is the word than. Hawaii than Kentucky. So that's another way of saying Hawaii minus Kentucky. And for Hawaii, I'm going to estimate about 14 cents, maybe. That's Hawaii. And then Kentucky is about 4 cents. So I would subtract those. And then I would be very, very careful. The answer is not number 2. That is $10. We want 10 cents. So there is about a dime's worth of difference between those two. Alice buys a sandwich for $2.25 and a drink for 75 cents. She pays with a $10 bill. Which expression shows how to find the amount of her change? Change indicates subtraction somewhere. I like to put these in my own terms first. So Alice has some money and she spends some and she buys 2 things. She buys a sandwich and a drink. And then once I get that written, I have my answer. I know that she had $10. The sandwich was $2.25. The drink was $75. So I am looking for something like that. I can eliminate 1 and 3 because they don't start with $10. I can eliminate number 2 because the drink did not cost $75. So it has to be number 4. And it is number 4 because I need that addition sign. I need to add the sandwich and the drink and then take away from $10. Number 5 technically would work. Let me just run that through. I don't see a thing wrong with that, but I am sleepy, so let me just be sure. Yes. Technically, number 5 would work, but it's number 4 they want. That could possibly have been a misprint. What do my directions say? They don't say. There's an algebra reason that number 5 would work. You would not need the parentheses. I'm sorry. I'm just going to let that go. That one bugs me just a little bit. To save postage, James is mailing several items in one box. 2 of the items weigh 13.9 pounds and 20.65 pounds. The packing material and box weigh 0.3 pounds. The maximum package weight the post office accepts is 70 pounds. Which expression gives the maximum weight for the remaining items? So let me think how best to, I'm going to do it this way. The box itself and the packaging weigh 0.3. Two of the items in the box weigh 13.9 pounds and 20.65 pounds. And the max that the whole thing can weigh cannot go over, all of that cannot go over 70 pounds. So that's essentially my starting point. I cannot exceed 70 pounds. So we are looking for how many pounds are still available to work with. How many pounds could the remaining items be before I would have a problem? So my reasoning looks like this. 70 pounds minus the first item and the second item and the packaging. Okay, so I would have 70 items, or I'm sorry, 70 pounds minus the first item and the second item and the packaging. And one thing you would want to be very careful about is that everything is in terms of the same unit. And in this case it is. Everything is pounds. If you had ounces or kilograms or something in there, you would have to adjust that so that they're all the same. But they are all the same. So I can eliminate question or options 3 and 4 because they don't start with 70. 70 is the max we could have. So that's the starting point. I could eliminate number 2 because it does not subtract the 20.65 and the 0.3. Same thing with number 5. It doesn't subtract the 0.3. It just subtracts the 2 items. So that the only one left that fits what I need is number 1. You would take the 70 minus all that other stuff, and that would tell you how much is left over for your remaining items. Okay, don't get upset about this one. We'll take care of it. If you're taking the high set, you will not see this type of answer, at least not in the current version. But don't let this throw you. If you're doing the GED, you can do this. Haley swam the 50-yard freestyle in exactly 25 seconds. How much slower than the state record time of 23.156 seconds was Haley? And I want you to highlight this word. Slower. That is a subtraction word, especially that ER on the end. So they're telling me you need to subtract here. So I will take Haley's 25 seconds, and I'm going to do some lining up here with decimals. Then 23.156, and everybody needs the same number of decimal places. And this sets up my subtraction problem. All right. I cannot just bring down the 156. We have to do subtraction. So I'm going to borrow, and I can only give that to the first neighbor. But I can borrow one of those and give to this neighbor. And borrow one of those and give to this neighbor. And now I'm ready to subtract. 10 minus 6 is 4. 9 minus 5 is 4. 9 minus 1 is 8. There's my decimal point. And 4 minus 3 is 1. That is the answer that I will grid here. All right. So if you're taking the GED test and you get one of these, here's how you do it. You can start here. You would have to start there because you need space for all of these. So write your answer in here and then very carefully fill in the bubbles. The computer cannot read the numbers. It only reads the bubbles. So make sure you fill in the circles. Just writing it in there is not good enough. You have to find the answer and then bubble it appropriately if you're asked to. This is not a multiple choice answer. So 1.844 is your answer. All right, number 5. This is a calculator question. The Walkers pay for each kilowatt hour of electricity they use. Their friends in a neighboring state pay how much more? There's that phrase that's so important. How much more? That's subtraction. Do the Walkers pay for each kilowatt hour than, there's another subtraction word, their friends? So you can use your calculator. You could also do it longhand. Oops, I'm about to make a boo-boo because I'm getting in a hurry. If you're doing it on the calculator, you just type it in. And I think I'm going to, just because they tell me that I can. 0.1165 minus 0.095 is 0.0215. I like option 1 here. Be careful though. Look at number 4. It's awfully close. So just be sure you pick the correct one. And finally, number 6. At the beginning of August, Juan's checking account balance was $589.86. Then he wrote checks in the amounts of $18.12 and $50.43 and made a deposit of $40.11. What is the balance of Juan's checking account now? Again, I like to put it in my own words. So in August, he had some money, and then he wrote a check. That's a minus. I'm going to say that's check 1. He wrote another check. Let me use the right word here. Let's use and. Check 2. And then he made a deposit. That's addition. And we want to know the balance now. So in August, he had $589.86. Check 1 was $18.12. and check 2 was $50.43. And then a deposit was $40.11. And there's no calculator on this one, so we're going to have to do this longhand. The first thing I'm going to do is my parentheses, because that's what order of operations tells me. So I will say 18, actually let me do it up here because I don't want to mess up my problem. So $18.12 and $50.43, those are being combined because they're both checks. So $68.55. And then I am going to bring down this balance and subtract that one. Be careful that you copy things correctly. Maybe it's just me, but that's where I really make mistakes, especially if I'm in a hurry or I'm not paying attention. So this amount, actually, let me keep the color scheme going here. This amount, when I did this math, gave me $521.31. And then I'm going to add that deposit that he made. And I'll use blue to do that. So $521.31. It'll be a miracle if I get all this right. I do not do this kind of math well, but we'll see. It is multiple choice. If you were running out of time, just make a good estimate. And there it is, so I guess we're okay. $561.42 is the current balance. Again, if you have not done the computation review, I strongly encourage you to do that because that will help you with this kind of stuff. Helps you be accurate and fast with those. It just sort of supplements what you're doing here. But please do not overlook those.